The 7 basic quality tools can solve more than 95% of the quality related problems within a company. And as a quality engineer, one of the most important skill that you need is the ability to solve problems and improve a process. These basic tools are basically means of collecting and analyzing the data, identifying the root cause and measuring the result. So without wasting any further time, let us look at all these 7 QC tools one by one. Hello and welcome to yet another video series from Digital Learning, your one-stop solution for all your learning needs. So before going into more detail, let us first understand what are these 7 basic QC tools. So the Karu Ishikawa developed these 7 basic QC tools so that the average person can analyze and interpret data. These 7 basic QC tools are Pareto analysis, fishbone diagram, control charts, histogram, check sheet, process flow diagram, and scatter diagram. They are called basic because they are suitable for people with little formal training in statistics and can be used to solve the vast majority of quality related problems, and they deal with facts, data, and not the opinions. It is said that 95% of the problems can be solved using these 7 basic QC tools. These tools are perfect for establishing a baseline, gaining consensus, deep diving into the root cause, and monitoring the effectiveness of implemented solutions. These tools have been used worldwide across companies and managers at all levels and employees. Let us look at each one of them one by one. Histograms is a graph that shows how often a value or a range of value occurs within a given period of time. Histograms provide a visual summary of large amount of variable data, where each bar represents an attribute of a problem or situation and the height of a bar represents its frequency. It was first introduced by Carl Pearson and is used to tell if the process meets the customer requirement or not. It is a tool used to visualize the distribution of continuous data. If a histogram is normal, it will show the bell curve. So, to understand the method behind constructing a histogram, imagine a set of values that are spread across a number line. Here, we have divided the number line into 5 chunks. Next, count how many data points sit inside the each bin and draw bars for each bin whose height corresponds to the number of data points. Finally, you have the shape of a histogram. The shape of a histogram can vary. So we can have different type of distributions here. If we have a bell-shaped curve, it is a symmetric distribution. But if the one tail is longer than the other, that means the distribution is skewed. It can be left skewed or right skewed. For left skewed has a long left tail. It is also called as negative skewed. And right skewed has a long right tail, and they are also called as positive skewed. Apart from that, they can have two other different distributions, like they can have a bimodal or a multimodal, or they can have exponential distribution. So these are not the all the distribution. They can have n number of distribution, but these are the most common distribution you can exhibit from the data. Pareto diagrams or the Pareto chart is a statistical line graph that is basically a combination of bar graph and line graph. It is named after the Wilfred Pareto, and it is a type of chart that contains both bars and line graphs with horizontal axis representing the categories of interest rather than the continuous scale. These categories are often defects. The bars are presented in descending order from tallest being on the left side and shortest being on the right side. Therefore, looking at this diagram, you can see which one are more frequent at glance, and the line represents the cumulative percentage of defects. The Pareto principle says that the 80% of the results are determined by 20% of the causes. It is also known as 80-20 rule. And in short, You should focus on the 20% of the causes that are causing 80% of your defects. Turan went on to say that the Pareto chart helps us separate the vital few from trivial many so that we can concentrate on the vital few for our further process improvements. Control charts. It is the best tool for monitoring the performance of a process. Control chart is a time-based statistical graph that reflects the behavior of a process over time, including the normal variation and if there is any special cause of variation. And all this happens in real time and reflects the stability of a process. It is basically used to determine if the process is within the statistical control or going out of control. You can use the process control to track the value of process over time. It is the best tool for monitoring the process performance. It contains the upper control limit and the lower control limit that are the statistical base which represent the voice of customer or process. They are also known as Shewhart chart, named after the Walter A. Shewhart, or the process behavior chart, and allows you to identify the following conditions related to the process that can be monitored. It helps you identify the stability of a process, the predictability of a process, identification of the common cause of variation, special conditions that can be monitored. And if you talk about the different types of control chart, so the control chart are basically classified into two categories. On broadly, it depends upon the type of data you have. If your data is continuous, that means it can be measured on a continuous scale like thermometer, weighing scale, or tape. And if it's attribute data, that can be counted like good or defective parts. And under continuous data, we have the IMR chart, that is the control charts for variable. Then we have a X bar R bar chart and X bar chart. And under attribute, we have the two categories: defective items and defects per unit. Under defective, we have defect per unit, we have P chart and NP chart. And under defects, we have C chart and the U chart. So when the thought comes which chart to use, so if your data is continuous and you cannot subgroup into any grouping, then the best chart is the IMR chart. And if you can subgroup it, and if the subgroup size is less than 8, the chart you will prefer is the X bar and R bar chart. And if subgroup size more than 8, is the X bar and S chart. And when it comes to attribute, if your purpose of count is the defective items, then we have proportional defective, that is P chart, which plots the fraction defective over time. Here the subgroup size does not have to be same each time. This means that sometimes you can have say 20 participants and at a different time you can have 25 or 30 also. But the NP chart plots the number of defective over time, but here the subgroup size has to be same each time. That means you have to have 20 participants each time. And if an item is complex in nature, like a television set or anything else, it does not make any sense to characterize as being defective or non-defective, because a television may have many scratches on its surface or its screen. But the defective hardly makes any television a defective. The real issue here is that how many defects here are on the television set. So we normally have two types of chart under defects per unit: a control chart, C type control chart, and U type control chart. The C type control chart helps to plot the number of defects over time. Here the area of opportunity must remain same over time. And when we talk about the U chart, that plots the number of defects per inspection unit over time. Fishbone diagram. So fishbone diagram is a common tool that we use in the analysis phase of Six Sigma DMAC. This tool is basically a visual tool that is used to identify, explore, and graphically display all the possible causes that is related to the problem to discover the ultimate root cause. It is also known as cause and effect diagram or Ishikawa diagram. The design of a fishbone diagram looks like a skeleton of a fish, where typically we start from right, that is the effect, and to the left, with each large bone represent the major cause, and small bones represent the minor cause. A typically brainstorm session is required to figure out all the possible causes here, and then you start filling those causes in that root cause, main cause, and the primary cause as well. Scatter diagrams. Scatter diagrams are often used to help us understand how the two variables are related to each other. So when it comes to relationship between the two variables, this is the best tool. Suppose if you want to understand the is there any relationship between the number of visitors and the average daily temperature on the beach, then you can plot all the points and see that what is that relationship between these two variables. So you plot the independent variable on the x-axis, that is the temperature, and dependent variable on the y-axis here. With this graph you can see that there is a direct relationship between the number of visitors and the average daily temperature. This is governed by equation y is equal to mx plus b, where y represents the dependent variable, m represents the slope of line, x represents the independent variable, and b represents the y-intercept. So when we can have following types of correlation between the two variables, these are the most common relationship. When we have a direct perfect positive relation, that means the x, as the x increases, y also will increase. High positive correlation, low positive correlation, and there is no correlation, that means if the two variables are hardly will affect each other. And we can have also have the negative correlation, that means if one variable will increase, the other variable will decrease. That means if there is the x variable will decrease, y will increase. Then we can have a low negative correlation, we can have a high negative correlation, and we can have a perfect negative correlation. That is how we can figure out whether the relationship, how there is a relationship between the two variables. Check sheet. Check sheet is basically used for gathering and organizing the data in the real time at a location where the data is generated and then later analyze the data. Data is captured can be in the form of a quantitative data or the qualitative data. So this check sheet is not just one of the SunQC tool, but it is one of the most primary tool that is used in major phase of Six Sigma DMAC to collect the data. People often use check sheet to collect data on frequency, location, and even the cause of the problem or defects that occur during the production. The best check sheet that contains something more than data, they contain the metadata. So what is this metadata? Metadata is a data about the data. Like you collected the data, when, date, shift or time data was collected, and where, like location, equipment number, all these data collection took place. Without metadata, the actual data can become ambiguous and may lose its integrity. It is also known as tally sheet. Process flow diagrams or the flow chart is a graphical visual tool that will depict the flow of process or sequence of a process and helps you analyze how the problems occur and how the process can be improved. This can include the flow of information, task, people, material, or decision. Take the example that my lamp does not work. So lamp does not work. So we will first check, is the lamp plugged in? So if the answer is no, then we need to plug in the lamp. If yes, then we need to first check, is the bulb burnt out? If yes, then we need to replace the bulb. Otherwise, we will repair the lamp. So the flowchart can make the complex process become simple and promotes a common understanding of the process, which is the foundation for improvement. One common mistake with flowchart is that they are often created in the conference room away from where the process actually occurs. There are some specific tools that help you draw this flowchart, such as MS Visio, and they are some of the most common symbols that we use in constructing a process flow diagram. So that is all I have on this video. See you soon in my next video.